Let me take you through our speakers. First of all, Valdemar is back, who is an AI team lead at Smart Data Inc. And Valdemar, do you run one of our chapters?
Yeah, kind of the Berlin one.
Right, that's what I thought. So we have one of our chapter leads from Europe, which is always a pleasure. And let me tell you something, guys, being a chapter lead is a lot of work. And so I greatly appreciate when someone who is already doing a lot of work for the organization takes the time to prep and do one of these sessions, because it is a lot of work to prep these sessions. And the second is Sophia Skoronsky, who is at Breckenridge Capital. I've introduced Sophia before, and I've had her actually talk to my son, believe it or not, who is a physicist out of MIT and a researcher there in climate and sustainability. He was very grateful, by the way, Sophia, for your time. And she's a data scientist, which I haven't figured out, Sophia, how you are a data scientist at, and by the way, we are recording, right? Let me check.
Yeah,
Yep, we're recording.
Wait.
How you can be a data scientist at a venture capital PE firm, you're going to have to explain that to us someday. Okay. Not at the
Yeah,
moment.
sure.
Not
Yeah.
at the moment. And you
Today
can
it's all
see,
about MCP.
okay. You can see our LinkedIns. We do like you to contact us and connect with us. It's always great to be talking to members of the community. Let me just say, if you do connect with me, I get like 10 invites a day. Please, in the note where you say, add a note, when you connect, say, I heard you or met you through MLOps community, because otherwise I will reject the request. And I'm sure that's true for Valdemar and Sophia as well, especially since Sophia's in the fundraising business. I bet she gets hit like 10 times a day for people who want to connect with her to see if she has any money to invest. Okay. So the agenda today is Valdemar is going to start. We lost one of our speakers. He couldn't make it today. So Valdemar is doing double duty. Thank you, Valdemar. He's going to start with the abstract and intro, as I understand it. Sophia then is going to go through the methodology, which is really interesting, and then also the results. Valdemar will jump back to do the results. We have questions at the end. The link to the question document is in the chat. And so you put your questions there. You'll see I actually added one already of my own. So you can follow that model where you put your name and then your question, because I will call on you when the time comes. I'm going to call on you if you put a question in to ask your question directly. I'm not going to be the mediator for question and answer. You can talk to the speakers directly. Now, guiding principles of the reading group. These are your, and I do these all the time. You're probably bored of hearing me say it, but they're important guides. First of all, these are your sessions. They're meant for you to learn. The more that you participate, the more that you ask questions, the better these are going to be. Okay. And we've had great interactions in the past. It's really added value, especially when people who are actually doing something like multiple agents on MCP say, hey, I was trying this, I found this. Why are you saying that? Because it's not what I'm seeing. Those kind of comments are really valid and very valuable. Excuse me. All comments are valid. Also, this is a no judgment zone. I want to be very clear. There are no dumb questions. No one is here judging you to say, oh boy, is this guy smart or not? We're here to learn together in a safe environment. So please bring that attitude to the session. Lastly, Valdemar, I think you're going to show a Miro board. I just want to be clear. People are going to ask, hey, can I get a link to the Miro board? That Miro board, confirmed for me, Valdemar, is view only.
Yeah, it's me and Sophia have access, but I cannot make it public, so unfortunately not. But it's just snippets, mostly from the paper and a couple of things from Sophia that you'll see in the presentation.
Very good. And always, guys, we want to serve you. You are our customers, if you will. I'm a product guy, so I always think like that. And we want these sessions to be a great use of your time. Not even kind of a good use, but like a fabulous use of your time. Filling out the post-event survey helps us do better every time. So please do fill out the post-event survey that will come in your mail. And at that point, I'm going to stop sharing my screen and turn it over. How do I do that? Stop share. And I turn it over to Valdemar. Go for it.
Yeah. Thanks. I'm sharing my screen. I will put this into presentation mode. Where is that? So we have this Miro board. I will scroll down. Do you see it?
Yes.
Yes. All right. I'm gonna just cover the introduction, hand it over to Sophia, and then we will. I'll talk about the results. We'll have some comments in the end. Just first, quickly go through it. It's not a very long paper. It's mostly just a description of how this benchmark was made. So what is it and what is it about? Live MCP 101, stress testing and diagnosing MCP-enabled agents on challenging queries, was basically about building this 101 example benchmark or test environment for benchmarking or measuring the effectiveness of different agents. Sophia will talk about more the methodology, how they constructed it, this kind of synthetic data with human overview against MCP tools and servers, what they can do. Yeah, they made this evaluation approach, which was also like another one of the main contributions. It was a bit special, or they were kind of evaluating that the agent went the right path in selecting the tools, because the benchmark is about these challenging input queries. The agents are not chatbots. They're just more like if you're familiar with the code assistants, where you can just tell the code assistant, hey, let's make an app that does this and this. And he has to decompose it into a plan and return the right answer. So we'll learn about that more about that in a bit. And they use the benchmark to evaluate different frontier LLMs. So basically evaluating the different foundation models to see which ones are best. And yeah, it turns out you cannot quite yet just ask LLM with MCP tools to do anything you throw at it, especially not these challenging queries. So they're actually a bit peculiar. I thought they were hard when I was trying to understand how to do them. They're also just a bit weird. We'll see them in a bit. Then we have a bit of a failure analysis, like what's failing in what models. It's different in the leading proprietary models versus the open source ones, for example, or smaller and bigger ones. We can have a little look at that. So here's the big picture. I guess it starts here kind of in the user query in the middle. I'm assuming you see my mouse. We have the MCP tools. So maybe before going to that, let's have a look at what is MCP, kind of assuming people are familiar with these LLM AI assistants. And that's part of the related work, is that we have now these agents with tool use. And you can make your own tools, but a lot of people in the last year or half a year have been publishing their tools using the model context protocol that was made by Anthropic last year, which is like a standard protocol similar to, like HTTP, or supposed to be like the USB of porting tools between agents and systems. USB-C or something, and now it's porting data everywhere. And you can make an MCP server with your tools and make it kind of open source, and there's a lot of options. I've used it a bit, but I heard that there's a lot of MCP servers and a lot of tools, but I'm not sure if there's a lot of users actually using them. I'm not sure how well that technology has been realized, but in theory you can, like they do in this paper, give the agent access to whatever. Here they are, travel, you need to find the hotel or flights or whatever, coding tools, and just pull that in, add it into your AI agent's prompt. Basically, you give it the documentation for the tool, and he can use it to solve your query or your problem. And doing that, he has to make a plan. And what they do is they like construct these queries and how this real plan should be. That's what their contribution was. And end up with this benchmark of 101 different queries and accompanying paths that you should solve to solve a task. So yeah, let's say you want to something about the hotels. You want to find one of the examples in the paper was related to finding accommodation not too far from a basketball game for a specific team. And these are like different data that needs to be pulled in and merged kind of. And you'd use a tool for Airbnb, for the hotels or whatever, Airbnb's, Booking.com. That's an MCP tool you call, and you have the Google Maps API and the NBA MCP tool that apparently somebody published. And then it's all evaluated using this LLM as a judge, which we my headphones disconnected. Can you confirm that you hear me? Is someone there?
Yeah, we can hear you.
We can hear you.
I'll be without the headphones then. Yeah, it's a lot of AI generated stuff. So it's like maybe a limitation that you have the AI evaluation, AI generated benchmark to test the AI. And that has some effects. For example, we know that certain language models prefer their own kinds of texts. So it's all generated by GPT and not Claude and whatnot. And that might affect how it's evaluated by, I think it's evaluated by OpenAI as well. Anyway, so this is a big picture. Synthetic benchmark, AI evaluation. And you can use this to evaluate different foundation models like they do, but you could also use this benchmark just to test different prompts or different tool selection components or whatever you want to experiment with for your agent. And the benchmark isn't out yet. The paper is out. I found the guy, one of the authors, texted him and he told me it will be out soon. But like, should be useful for I mean, yeah, benchmark should be used, not just like, it's not really science, it's more like an engineering tool. Now I'll hand it over to Sophia. Do you want to control the screen? I can also scroll.
Yeah, I think I can control it, right? Yeah, looks like it. Sorry, first time using Miro, but seems like we set this up easy enough.
Do you want to share? I'll give you the.
Yeah, I'll share. Sure. It sounds good.
Sure.
All right. Yep. Okay. Great. So you should be able to see same screen, right?
Yeah.
Cool.
You could go to presentation mode.
Let's see.
Yeah.
Yeah, let me see.
Hold
on, sorry. Share
it was one of the
public join. There we go. Well, this is as close as we're gonna get. Sorry, guys. But so I'm just gonna quickly walk through.
Can't see your screen, Sophia.
You can't?
No.
Okay, so let's try it again. Sorry, guys. Okay, let me. Okay, the Zoom share screen just.
I think I can see your screen, Sophia. Voldemort, can you not see
sorry,
it?
my bad.
Yeah, it just looks the same. It just looks the same as mine earlier, but I think it's yours now.
That's me.
I'm under control now. Yeah.
Right.
Was like the Zoom disappeared. Okay. Anyway, so as Valdemar said, I will be covering the construction, the evaluation design, and the experimental setup, which is in like this middle of the paper. So we'll just start off with the construction of these queries and these execution plans. So the goal of this data set, this benchmark, is to push these LM agents beyond just mere toy function calls, which they kind of describe as, single step calls using a synthetic environment like a mock database. And they want to generate 101 tasks that combine realistic user queries that can be used across multiple domains and most importantly, are in dynamically changing environments because, the real world is the actual test for LLMs in production. So they mentioned each of these tasks that they generated had to meet these three qualities. They had to be solvable. They had to have a verifiable end state, and they could be easily mapped to some level of difficulty, so easy, medium, and hard. Pretty straightforward. So first step for generating these queries was to first sample from a domain. And in the longer paper that I put in the chat, they created this little pie chart that kind of covers all the domains that they found within these 41 MCP servers that they used for generating the benchmark data set. And so you can see the pie chart, because it's not a bar chart. It's hard to tell which one's the largest one, but in this case, the largest domain was travel and leisure, followed by software development and office. So they use GPT 4.1 to select the domains for each of the 101 tasks. Let's see if there's anything else there. Yeah, and so next step then, so they know what type of domains they're going to use to generate the queries. The next step is actually generating some queries to use in the benchmark. So they use 4.1 to sample the domains, and then they use the O3 reasoning model to create the initial natural language queries. And so they had these queries generated, they mentioned conditioned on the specific domain and specific tool specifications. So they wanted to make sure each query just naturally led itself to multi-tool reasoning. And they stated in the paper that some of these initial rounds of query generation were really messy. So they did multiple rounds with manual revision. And so the final outputs for each of these, they determined met those like three qualities that I listed, that it's, and especially that it's clear, which seemed to be an issue with some of the generation of these early drafts. So from there, that led to 101 tasks that could be segmented into these three different categories, with tool chain lengths between 2 and 15, average being 5.4. Not that exciting, but so then we have these like queries here, and how do we go about evaluating the plans for these queries? Will the final output be enough? And the authors make the case that no, it's not enough, and this is why we need this new type of benchmark, because MCP servers run on live time varying data. So using just ground truth outputs of these queries at any given time may drift between runs. So they created these ground truth execution plans. And again, the longer paper has these examples in the back. So again, how did they create these execution plans? Very similar to the queries themselves. They use the O3 model to draft. And again, they compared the draft. Yeah, so they just did multiple rounds of drafting where they had humans in the loop, these 120 PhD hours, to check that there's like no errors in the logic. Let's see, the tool choice is correct. The parameters to invoke the tools are correct. And just overall, it's following a logical output. And so then, so they, yeah, generate these execution plans. The PhDs got to go home, and the resulting set is 101 queries plus these gold standard tool invocation chains, as they kind of referred to it. And so is this kind of begs the question, are these human validated plans the only valid trajectory for all of these queries? It could be for some of the easier queries, probably the very simple ones. But you can kind of say that there's probably multiple valid solutions for some complex queries. So we just need to keep in mind that potentially we're favoring models in this benchmark that mimic these human validated tool orderings. Um, and so I think that's kind of the gist for construction. And so that kind of covered this first half of, if you can see my mouse, of course, this first chunk of the diagram from the paper. So now we're kind of going to go through the evaluation framework pretty quickly.
Sorry. Can we maybe look at one query and path just to make it more concrete?
Yeah. So
The
I don't. Yeah, this
hard
one's
one
a
is
good one.
weird one. Yeah.
You
So
obviously don't have kids, Valdemar.
the speak in riddles. Yeah. It's this one's kind of funny, like realistic user queries. I think there's an even stranger one that I could go to, but this hard query starts off with a riddle. First, like you need to know what MBA team your 9-year-old son is referencing. And then from there, come up with like a travel itinerary using like Airbnb pricing, and figure out like walk score of all these Airbnb addresses and produce a report to kind of surprise your son with a vacation. Yeah, with a spreadsheet. Yeah, they love that stuff. But yeah, so you can see the riddle itself is not part of the tool calling because in theory, the LLM has read all the Wikipedias for the NBA teams and all of Steven Spielberg's films. So in theory, it's supposed to get that it's who is it? Toronto? I don't know basketball at all.
It was the Toronto Raptors. That's the Raptors were famous. It was like it was named in '95 back when Jurassic Park was the biggest movie. Yeah.
And I think sorry.
No, just the Velociraptors. Yeah. Anyway, go on.
And it's the movie Ready Player One, right? That's what we found.
That was what Jem and I told me, but it's definitely Jurassic Park because of the dinosaurs.
Yeah. Duh. Okay, got it. So the first step of this execution plan is to look out 60 days from now when they want to travel, figure out like the ideal check-in and check-out dates based off of 60 days from now, which is the second tool call, which is just Python execution. Then the next tool is searching Airbnb listings, given the region and the dates. And then step 4 is using a Google Maps distance matrix tool, which sounds pretty cool. I've not used that. And so it allows them to basically get the Airbnb information with the walking data, and then in the final 2 steps, process it into like a table and then write to a markdown file. And so I guess like that could be the only way to do it. But yeah, I'm trying to think like you can probably look at the appendix, Valdemar, or we can look at the end. But there's a really complicated one too that I wanted to highlight. But so yeah, that's kind of the gist for what some of these execution plans look like. So in terms of evaluating, as Valdemar already alluded to, there's parallel. There's a parallel design here, and that's to again ensure that the time varying piece is not an issue for the live MCP servers. Each task runs just 2 agents at the same time. I don't know if it's just 2 PhD students pressing play at the same time or if they have some like caching MCP server process going on. They didn't really go into that level of detail. I'm guessing that when the code and all of the queries are released, you could dig into it a lot more in more detail. But in any case, so there is a reference agent that is GPT 4.1 that strictly follows a validated execution plan that the human validate execution plan that I showed above, and its intent is to produce the reference output. And then there's a test agent, which is one of 18 reasoning LLMs that only gets a natural language query and a predefined set of MCP tools. And so it must do independent reasoning, it must select its own tools, it has to choose and write the parameters and tell and also indicate when it's done finding the output. And so again, temporal drift and APIs, so they do it at the same time. Like if they're one of the examples they gave was like YouTube engagement stats. So again, like I imagine like YouTube likes for a video can change by the minute. So again, like having these run at the same time is very important for having similar comparable outputs. How did they set up each task run? So you can kind of see it in some of these listed settings here. So each task is run once per test agent, and I'm not 100% sure if that's the case. It kind of seems like for each of the 18 models, they just run through the 101 tasks one time. I'm not sure if that's for budgetary reasons. And then each task or each agent run is limited to 30 iteration rounds. And then I already mentioned that there is a predefined MCP tool pool, which contains the essential tools required to complete the correct solution. So this was also generated at the same time as the queries and the execution plans, but they also added per task different sets of distractor tools that are drawn from unrelated servers. And so that's in the range. So each task had its own specific tool pool that was around 15 MCP servers and a range of tools available depending on the task. Again, just to prove that each agent can discover and like use the right tools and ignore the noise. And they say that this replicates real world production conditions, which I'm not necessarily sure that is the case, that you would throw in a lot of distractor MCP servers when you're building an application. But again, I think this is really just to stress test for the purposes of making it as complicated as possible to see how well they do. Yeah, let's see. So again, so the tool pool, and so each test agent has the same prompt using a React framework. And I think you can still see my screen, right? And so here's, I think some of us have either used React before or have seen this before, but yeah, it's all they're getting is the query, and these are the steps that they need to take in order to produce the output. So they want them to think about it, execute a tool call, and then observe the results, and then go back to thinking again or determine if their thinking is done. So yeah, let's see if there's anything else. And then what's interesting is, again, using 4.1 as the reference agent and using a separate one for the judge. Let's see. Yeah. So yeah, they want and then okay. And then for evaluation, there's a big table that Valdemar will run through, but just to give everyone a sense for what these two metrics are that are being reported. So the LLM as a judge looks at each test agent's outputs, compares it to the reference agent's outputs, and also compares the execution plans given the reference output. And so there's a prompt at the back of the paper where they just ask the LLM judge to rank between 1 and 5, 5 being the best, obviously, but they are ranking basically the outputs themselves and then the trajectory. And so for the results, which are in the paper, they basically look at all of the runs for a given LLM test agent and look at the proportion of tasks with a perfect score and then the average of all score, and same for these other two groups of metrics. They're mostly used in additional plot in some of the additional resulting plots, but the trajectory score is just the same. It's just the mean score of the trajectory for per LLM. And then there's some sense of efficiency for average token consumption and average tool calls. So all these metrics together should capture whether an agent first solves a task and second, how efficiently it does it. And so, again, a big contribution here is the fact that they created a dynamic MCP benchmark, since, as they state in some of the prior work, that most benchmarks only compared static references and outputs. And so that's pretty much it for methods. So I'll hand it back over to Valdemar. I first must stop sharing. Yeah, there we go.
While we're resetting here, please, guys, if you have questions, feel free to put them in the question document.
Yeah. Well, okay. I was gonna try to go full screen here, but the option disappeared. This should be fine. I'm gonna look at the results. Do you see the main results table? You can also look at the graphs.
Mark, can you take me off the screen?
Yes.
Just close it.
Close it.
Thank you.
Okay, so what stands out here? We'll look at the graph in a bit. But so what did they compare? Yeah, they took all the models from this summer. It's before the new Claude dropped. So GPT-5 was here, so a couple of months ago. We have the GPT-5, the 03, the 04, the Claude models from except the newest one, and then a few open source ones. There's Qwen 3 and Llama, and the small Gemini and the large Gemini. So Google, OpenAI, and Anthropic. All right, they tested it on the 101 tasks, which can be easy, medium, or hard. And looked at the overall task success rate and the average result score. So the task success rate here is what, 58%. I think it would be an even number if it were 100 tasks. So it's a number of tasks it fully completed. It got the 5 out of 5 score by the AI judge. So it varies from 1% or one task fully handled by the 8 billion parameter Llama, and one easy task, to 58%. And the average score, which, I mean, I guess sometimes it would answer most of the query or question. It would find you some hotel. It's maybe not the closest hotel to the basketball game or something, and it gets 4 out of 5. Then 73% was figured out by GPT-5, and interestingly, only 41% for GPT-4o. Or I thought it was interesting because I'm still using GPT-4o a lot. I felt GPT-5 was a disappointment, but apparently for these kinds of tasks, first of all, the thinking, reasoning really matters, and the size of the model. So I guess GPT-5 is very similar to 03, but considerably better at this. So it's not the failure a lot of people said. You can see it won all the different in all categories. We have some graphs. Here we plot. It's just looking at both the task success rate and the average result score, which obviously is very correlated. And it's colored. I'm not sure what the color was, but GPT-5 clearly the best. 03, and the clusters, we have these proprietary models where Claude falls a bit behind. We have the older generation, which is considerably worse. So you can see there's been a jump from 25% to 50% or 40%. Yeah, 25 to 40% from the last or older generations or smaller ones to the current ones. with extended thinking and post-training and whatever they do. And then the small ones, I mean, 8 billion parameters not going to do much. You can run that, like I'm using Qwen3 4 billion on running it on like a local machine. It's a different thing than these supercomputer machines. Then we have how wasteful they are in terms of tokens. And it's actually, if you're looking at expenditure, so the cost basically, GPT-5 was using 16, 17,000 tokens, and it was calling a lot, multiple tools. That's actually a lot. It's like the number of tool calls. It would like try some tool and it didn't really work and try another tool. But in the end, they would achieve, solve half of the tasks correctly. While O3 is spending half as much and, considerably worse, but still, it's like from 60 to 50. And Claude, way cheaper. And I'm not sure what all these tokens are. It's just calling tools and it's just talking to itself, I think. There's like thinking traces where it's doing extended inner dialogue, so to say. And they looked a bit into that population study where they tried to vary one component. Here is just the number of iterations. Probably should have kept the text here, but it's not that relevant. The top line is GPT-5, the winner. And if you could limit it to 15 rounds, then it wasn't that good. But when it had more attempts, so we would like try a tool call, an MCP tool, along with a self-thought or something. If you give it 20 or 25 attempts, then it becomes better. And the second place, which is like O3 or something, 4-1 or the lesser ones, they like it helped them to have room for mistakes, but then it plateaued. And that's why in the end they used 30 for this the final results. Even though you don't need 30 tool calls to solve a problem. The highest one, according to this gold standard, was 15. Sounds like a lot. And that's also worth to mention that these gold standards are not it's not necessarily the only way to solve the problem. There's infinite ways. And then I try to vary the number of noise in the data, kind of the MCP servers and number of tools they're sampled from. And if you added more tools, going to have like 15 servers with lots of tools about traveling or whatever, when it doesn't even matter because you're doing a programming task. And then the best one, GPT-5, was quite robust, and the tiny ones got confused. That's what this one was about. And an important result was the error review here, where they made this table, heat map, or whatever you call it, where they categorized the different types of errors. I can briefly talk about them. There were semantic errors and syntactic errors, so it were quite prominent. That's about tool calls. So you could have a syntax error when you make a tool call. You're going to find the hotels at the 5th of October, but it's a malformed date, or it's like a string instead of a date time parameter. The syntax error. And semantic error is when the input to the tool, the parameter used to call a tool, is just wrong. It has the right form, but you're saying it's October last year or something instead of this year. And all the tools tended to fail into that, but the bigger, the less prone to failure for that. Well, for the syntactic ones, the tiny model, or like not tiny, 70 billion parameters, it just wasn't trained on tool calling. It's an older one. So it just failed putting integers when it's supposed to be strings or something into the tool calling. Overconfident self-solving means when you just answer it without calling a tool. It's like, so I've made a lot of these agents for companies. It's one of the basic problems is to remind them all the time to look it up and not say like, yeah, yes, you can have a discount. Just look at the policy, call a tool. But GPT-5 is much better than GPT, like, I don't know, Claude 4 Sonnet, for example, at that. There were output parsing errors. I didn't fully get that. What that was, was something to do with the JSONs that came from the tools. We don't need to dive into the details. Tool selection is always a problem, and especially if you have these big sets of tools. So yeah, that's what I would think would be the problem. Yeah, it's the wrong tool selection and the semantic error. And the overconfident self-solving. I'm a bit curious about how high these numbers are. They're like calling to, I guess the documentation for the tool isn't good enough, because it should provide you with maybe a list of available options for the parameter, but maybe it was missing. It was like an API, and GPT was just hallucinating what could go into the API, but when actually it's only like 10 different categories. You can go into the hotel booking search, like 2-bedroom, 3-bedroom, or whatever. But yeah, overall, GPT-5's on top. I think Claude 4.5 could be there also. There's a big difference between the different types of error, or kind of big difference between the older and newer ones. And the types. I don't know what to infer from this. If there's any useful comments. Unproductive thinking remains a problem. O3. I remember when O3 came out, I asked it. I was kind of didn't know how to use it, so I asked it to give me the bash command to compress a folder into a zip, or like something I needed to do at the moment, and it would just talk to itself and think about it for a minute instead of telling me the command. So I guess that's a problem with the thinking models. But overall, the thinking models are much better than the old ones, and I'm going to upgrade some things to GPT-5 after this. Finally, they evaluated how good was the LLM as a judge, is the human LLM agreement. So they were wondering, like, does the LLM as a judge, does it really work? Do you agree? So you make a person evaluate the tool, like how well the task was solved on the 1 to 5 scale or something, and then you check the correlation using this kappa here or something. Okay, and overall it's pretty good, and regardless of which model was chosen, the humans tend to agree with it, kind of. However, this whole synthetic AI, having AI evaluate AI, is kind of flawed. So that's one thing. I recalled having read a paper a while back. It's when GPT-4 came out, but I think the same thing probably still is there, which demonstrated that GPT-4 exhibits a significant degree of self-preference bias. So using GPT-4 or any model as a judge may lead to excessive influence from GPT-4's unique styles and policies. So we have the benchmark was generated by ChatGPT, and then we're using ChatGPT to evaluate which answer was best. And here's some example from this, where it's from the old paper. Describe your current outlook of the financial markets and the US economy. And GPT-4 says it's some basic, not very useful answer. I don't have real-time data or ability to provide the current outlook on the financial blah, blah, blah. While some simpler model gave an answer that the human preferred. Currently, the US economy is in a period of expansion, or at least, a few years ago, and the financial markets have been performing well. But GPT-4 just likes its own stuff. So it's one of the fallbacks, or you say, limitations of this paper. We're done with the results. I had some comments I can maybe start with, and then Sophia, if you have some comments, and open up a little dialogue before we finish.
Why don't we take some questions?
Open up questions, yeah, sure.
From the floor first. I think your comments will go into, you're still sharing your screen.
I can maybe open the doc, or do you want to go? Yeah, you can share and look at the questions.
It's just
Sure.
I'm looking at me. I just don't like looking at myself on screen that way. All right, I'm going to start with Samantha because Samantha, you've obviously been doing some work in the field, watching your comments. And why not, first of all, tell us what you're doing. And by the way, everybody, we're in question A. If you want to show us, I know everybody's from some people are in their bathrobes probably, but if you want to go online and show us, who you are in the video, turn it on. That's always appreciated. So we're talking to each other, not to just pictures. Samantha, tell us what you're doing, how many tools you're using in your implementation, and what you found and where your questions are coming from, because you have some concerns.
Yeah, I mean, I think I've told you all about the projects that I've worked on in the past, but we did quite a bit of comparing across models on a few different kinds of tasks, but mostly things where we were asking the models to look at log data, or to read like a SQL query or a human question and translate it into a SQL query. And we definitely saw some things that are consistent with what they're reporting in this paper. So that was kind of validating. But some of the stuff like tool selection, I'm kind of wondering if it would be better to just have a lookup table or something. Like if the models are that bad at it, I would expect they should be able to get that right 99% of the time. And it seems like they're not. And I definitely have some concerns about, using LLMs as a judge with only a 5-point scoring system, because when we did that, we were finding it was very difficult to get a good enough spread to really evaluate. And especially since they didn't do enough replicas on the same questions, I would be pretty suspicious of their statistics. So I mean, I think it's really interesting, but I have some questions about the numbers. I think the general thrust of what they're trying to do makes a lot of sense, but some of the implementation I might want to redo if I was going to try and draw conclusions from this.
Let me follow up on that. I don't mean to be the person asking the questions, but I do have a question specifically related to this from the PyTorch conference that I was at yesterday, which if anyone, we had free tickets, and if you went, thank you for making use of them. I'm concerned that they only ran the task once, Samantha.
Yes,
because
that's a big one for me.
Yeah, because there's some studies, I actually have one on the screen, but I'm not going to share it, that show that in terms of reproducibility, model reproducibility on answers is very low. It's a wide range. And so how do you really know that the run represents the actual average of how the machine would perform? That's my concern. Do you agree? And Valdemar, Sophia, do you agree with that?
That's absolutely been my experience. And I've even had some kind of ridiculous conversations with people who said that they thought models should be deterministic or something. And I was like, that's not how these models work. But yeah, that's why I'm saying, like, if they could run the same question at least 3 or 4 times, then you would get a better sense for, are these really valuable results? But I could also see an argument for your typical user might not know that they should try it again if it doesn't work.
Right.
And so you could claim, like, if they only did it once, this would be their impression. But I think that's, again, just a lack of understanding of statistical thinking, and that whether it works on any one try is luck, basically. So,
well, and let me add something to that from yesterday. Also, the second paper that I was at the conference, which is one of the things that really caught my attention is when they did the runs over, they had the same data, but formatted in different ways, just in the query.
Yes.
And that changed.
That can make a huge difference. Yeah, exactly. Well, and that's why prompt engineering is an art. It's not just, I feel like a lot of people don't understand the value of prompt engineering and why it matters. Anyway, I will be quiet now, but thank you. This has been very interesting.
Valdemar, Sophia, any comments on any of this? Yeah, I see you nodding your heads.
Yes. Yeah.
Oh, go for it, Valdemar.
Yeah, just often researchers would run it, 5 times and get standard deviation or something, get like error bars or something. And then sometimes something that seems to be better is just luck. And one thing that you just mentioned is the paraphrasing, the sensitivity to slight changes in the input. That's a big thing for neural networks in general. So for these queries, they were all phrased peculiarly. And if you would just skip having a riddle in one of them, then maybe the less smart models would be able to solve the task. So it would be cool to have different queries that should result in the same output, because people write in different ways and whatnot, and test it a few times. So yeah, for sure.
Yeah.
But it costs more, I guess, obviously.
It seems like this is like it reads like the first draft of the paper, sort of, because you would imagine like the longer version we found had a lot more detail. And so I'm guessing that like if you were a reviewer, you would ask them to like use an ensemble LLM judge. You would ask the LLMs to not judge queries or executions written by the same family of LLM models. Like you wouldn't want GPT judging other GPT models. Basically what everyone else is kind of reading into this paper, it seems like they lack some good comparisons in their experimental design that would have made it a bit more robust and um, like a heck yes, like this is a great benchmark. But it seems like for the most part, like one time run through, just using GPT to generate queries. And I think someone made a comment about like the human evaluators. They didn't even go into the detail. They said it was a blinded um, human comparison test, but they didn't really go into the detail of like what part of the evaluation was blind. So yeah, it just seems like this is a good first draft of the paper.
Yeah.
I think there's one thing, something that didn't happen before and we have now, is like evaluating everything with an AI. Like if you're publishing a benchmark, maybe you should spend those 120 hours to just construct a benchmark, or instead of maybe it would take more hours, but seems like they weren't saving that much time on making the queries if they had to spend a lot of time reviewing it. And it's just like vibe coding a science, So it's a bit discerning. What do you say? Yeah.
All right, let's move on to the next question. Tamiz, there you are. Tamiz Zalai, if I said it correctly. Tamiz, if you can show your face, that's great. There, you have a question that was about errors. I think we want to ask it. It's a very good question. Could you phrase it in a broader context that you meant it? Because it's a very short comment you made in the chat.
Yeah, sure, Arthur. Let me turn my video on. Thank you. So, yeah, they provided that table where they categorized the errors by type, which is certainly helpful to understand where things are going wrong. But I'm curious, I mean, I have a lot of background in classification, and usually when a machine, AI gets something wrong, you want to look at the things that it got wrong and what are the patterns in those things, right? So is there some similarity in the hard questions? Was there something about the structure of the hard questions, the topics of the hard questions, the train of thought of the hard questions, or anything like that? I have no idea. And I'm sorry, I didn't read the paper beforehand, but I will read it now. I have no idea if they even included all of the queries in the paper. But I would be really curious to see that, because I think that would overlaid on their table of error by type, I think could be very informative about where these LLMs go wrong and what kinds of things they're good at and what kinds of things they need to be better at.
Any comments from anyone in the community that's on that? I thought that's a really good insight. All right, we have 2 minutes. I need 30 seconds at the end to talk about something that's related that we're going to do as another paper. But Brahma, you said and I think it's a great question. Could you ask it, please, or if are you still on?
Yeah, hi.
Hi, Brahma.
So you asked me about the 85% success rate,
Yeah,
or
I think that's a very critical question. Could you, if you want to show your face, that'd be great. You don't have to. You don't have to.
no, it's all right. Yeah, I turned my video on. No, all I wanted to ask, all the success rate they're showing, and particularly for other LLMs, the success rate is so low. So it seems that we can't even use it for anything. It's just, I mean, for any practical purpose, we can't really use anything. That's my challenge right now. And also, I made a comment also, since they use GPT 4.1 as a judge, LLM as a judge, and that might have, in my view, skewed the results in their favor of GPT-5 being top. I'm sure that definitely played a role, because if if you use LLM as a judge, that definitely favored their GPT-5 coming on the top.
1 minute, guys, just so our speakers.
That's all I want to say.
Yeah. One thing about this is that it was like a challenging query, and it's like a single attempt. It's more like you make a task for the AI and it's supposed to solve it by itself. But maybe if you had a chat with it and it would like ask you back questions, like the success rate would be higher. So I think chatbots can help you figure things out like in dialogue much better than these autonomous systems. So obviously we're far from autonomous agents, regardless of what people are preaching. Sophia, any comment?
Okay, I'm going to share my screen for a minute because it relates to this, and then we're going to say good night to everybody and good morning. I mentioned this paper. We just talked about verification by humans versus machines. This is a different approach to validation and verification. Instead of having a group ask one large group of people do a series of answers and tests against the machine, this uses a number of small groups and then combining what they call weak verifiers as a result into a single large unit. John Sod Falcon spoke. I've invited him to come speak, and I haven't gotten any pushback from the organizers yet that we should do this. So he's agreed to speak on this subject. I think it's a really good topic. It relates to the question of how they measured the performance of the human input, not just the machine input. And so that's why I wanted to mention it. And we'll let you know when that's going to happen. But that was just a follow on. If you want to look at this, there's a product or software that they've built called Weaver that does this. So if you're interested, take a look at the paper, and we'll catch up on a session on it when we have a moment. And with that, I'm going to stop the recording and wish everyone